So if we have e to the x, the inverse would be ln of x. Question, are their slopes the same? How could they be? E gets fast, ln gets slow. They're both increasing, but e to the x is getting faster as it increases, and ln is slowing down as it increases. Their slopes are different, but what is the relationship, seniors who are here, between corresponding points? What's the relationship of those two slopes? They're reciprocals of each other. And so we got this forever card, especially for our underclassmen in the front. We got this forever card where there are technically two ways to find the derivative of an inverse. We know the inverse notation is this little one right here. But really quickly, just for those, you never labeled our forever card. Fail. Sorry, this is forever number 17. I don't know how I can label it. Sorry. For those of you that might get a little confused by notation, this right here is the derivative of f inverse at x equals a. Another way of saying it is f inverse prime of a. Just a few of you, function notation is still confusing, and so you would want to multiply. This is not multiplication. This is of, like of x, but it's of a. So you plug in x equals a again. I said this in period 6 yesterday. I realized I never literally wrote it down anywhere. Some of you understand it. Some of you need this. This is f inverse prime, the derivative of f inverse at or when x equals a. Two ways of solving. One is with the formula, 1 over f prime of b, or you can switch the x and y and derive implicitly. We're going to start off with this example right here. We did two examples yesterday, but one of them, I guess we did this one 2 days ago. Anyway, we went over this one again. We had 2 examples yesterday, but the second one we did 2 different ways. One way, just so that you can label it this way, would be using the formula. Because if you notice, here's the formula right here. 1 over f prime of, why didn't I plug in the 6? I need b, and 6 is a. 6 is the x of the inverse, and I need the y to plug in. That's where it gets a little tricky. We'll talk more about this, but watch the video. It'll help in that I say most AP problems give ones that are easy to plug in unless you have your calculator. And it's like a nasty decimal, at which point you would graph them both and find the intersection, or move the 6 and find the 0. But otherwise, plug in 0, doesn't work. Plug in 1, doesn't work. Plug in 2, it works, yay! Use it, don't solve. Test, trial and error. That's with the formula. This one is with switching x and y and using implicit. This one is with switching x and y, here we go, and using implicit. They both lead you to the exact same place, and you, for both of them, need to come over, take the 6, set it equal to the x of the inverse, and solve for the y. So that's the same. What's different is how you find the derivative over here. Our example, we're going to do it 2 different ways. Just that's not the right color. That's the right color. Here we go. Let's start by using the formula. The formula. The formula says f inverse prime of, yeah, and then look up. It's weird. I wrote it in the directions this time. So 2 equals, what's the formula say?
1 over f prime of b.
Okay, I need to find this guy, right? Okay, so let's leave him blank. Remember, you can't play in the 10. All right, so we have 2 things we need to do for this formula. Who is f prime? And what's missing, right? We have 2 things we need. What's missing? Who's b? And who's f prime? So how do you find f prime?
Oh, you can divide.
Yeah, so derivative of x cubed is, got it. I would take the derivative of 2e to the x.
2e to the x.
He's the nice one, right? Stays the same. Okay. All right, so we have f prime. We're ready to put that in the formula. And technically, we could even say, okay, okay. I'm ready, but I'm missing who to plug in, right?
Yeah.
I'm missing who to plug in. So I have to come over here to this side and say, all right, 2 is the x of the inverse. Oh, wait, where is the inverse? I don't see the inverse. Do you see the inverse?
Let's make it.
Let's make it by switching x and y. So we're going to put x on this side, and we have y cubed plus 2e to the y. Now do I have an inverse?
Yes.
Yes. Where does the 2 get plugged into? He's an x because of his placement up here. So I'm going to put 2 in the x spot. Oh, I have to get y by itself? No, seniors, help me out. Try plugging in. Trial and error.
0.
I'm serious.
0.
0 works? 0. Because 0 cubed is 0 plus what's e to the 0?
1.
What's 1 over 2? So therefore,
Y equals 0.
that's 0. That's 0. Well, I can fill in all sorts of things. That's 0. Because the y is 0, I can plug in. That's my b. So I'm putting in 0 over here. So that's 0. 3 times 0 squared. Plus, what's e to the 0? And what's 1 times 2? So therefore, my final answer is 1/2.
Oh, I see. Something nice.
Was it your class that asked yesterday for what this means, or was that period 6? I'm going to get out a calculator.
What does it mean?
We're going to solve this a different way first, but I'm opening up my calculator just to try to show you a visualization of what this actually means. But before we finish that, let's go do implicit. Let's go do implicit. So I'm going to steal the exact same function.
So this is the formula, right?
Yeah, this is the formula way. The implicit way, guys, keep me honest because I don't have the equation right in front of me, but you do. The implicit way says, start with switching x and y. Yeah, you're right.
X equals y.
And then, okay, I switched x and y. This is my inverse.
Yes.
Find the derivative? Okay, fine. Derive both sides. This is alternative. An alternative. Derivative of x is? Derivative of y cubed is? Technically dy dx times y prime. Implicit, remember? What's the derivative of 2e to the 1? Times dy dx. Now we have to get the dy dx out, right? When you derive anything,
except x, it's a u, so you multiply by u.
Right.
So it's the 1.
because x prime would be 1, so technically we could do it with x also.
Yes.
Now, I'm going to divide 1 over. Are you guys okay if I switch the order, though? I want dy dx on that side.
Yeah.
Okay. So dy dx, it's like I'm flipping it and then dividing it. 1 over 3. Why am I not just plugging in 2?
Wait, real quick. Because you're still on the bottom. Holding on top.
I'm keeping this, I'm dividing, and then I'm flipping the sides because I want dy dx. Sorry, that is kind of confusing. Why am I not plugging in 2?
Because we have the
He's the x. I need the 1. So either way you solve it, you have to say what they've given me is the x of the inverse, which goes over there. Either way you solve it, you still have to figure out who's y. We already figured out y is 0. And as you see, it needs to go in the y spot. So either way you solve, we get the same answer. Now, if I was to take my graphing calculator, and if I was to plug in this function, keep me honest, make sure I'm putting in the right function. I just want to show you really quickly what we've just done. There we go. Can you guys at least back me up on the facts that we don't want to switch x and y and solve for y?
Yes.
Like, we don't want to get y by itself. That's awful. It's there. Actually, it wouldn't even be possible. But I could graph x cubed plus 2e to the x. Okay. And if I was to graph this, using our math off to the side, kiddos, if the inverse function has the point 2, 0, what would the original function's corresponding point be?
0, 2.
So I could go, my shortcut to get to second value, trace 0. I should have 0, 2 on this graph. Whew, okay, I have 0, 2 on this graph of the original function. What happens if I find the derivative dy dx, number 6? Batteries might be dead, sorry. There.
Reciprocal?
If I find the slope at 0, what should the slope be of the original at the corresponding point?
The reciprocal?
It should be the reciprocal. So if I plug in 0, is the slope 2? Yes. Now remember, the calculator does this approximation technique, so it doesn't always get it perfect. It is 2. It's exactly 2. You're more right than the calculator is. So on the original graph, the slope at 0, 2 is 2. So on the inverse graph, if you were to graph this guy, what would be the slope at 2, 0?
Oh, because that's an inverse point.
And then for the original, at the point 0, 2, the slope is 2. Can you kind of visually see it? This one's going steeper, this one's going less steep. It's hard to see the way I graphed it, but you can actually, if you can find that point, and you can use your calculator, if you can find the y, you can switch the x and y, you can plug in, take the derivative of the original, and then just flip it. But we have a formula, and how often are they going to actually let us use our calculator on this one? Probably never. But that's visually what's going on. Someone in period 6 asked me yesterday, I thought it was valid to show you. It might be helpful for visualization's
I
sake.
haven't touched my calculator in this class.
Huh?
I don't touch my calculator in this class.
So different than last year. Well, we didn't touch it a lot last year, did we? I did.
I write on that a lot.
Okay, I guess whether or not you were supposed to touch it. Well, alright, here we go. We got this. Ready? Set.
Easy. Oh, whoa, they gave you
Go as far as you can, choosing the method that you want. Do you like implicit or
Just go. You can just go.
Just go. Just go. Go team go.
Alright.
Once again, where did I get go team from? Usually steal phrases without meaning to. And they just stick for a year or two and then they're gone.
That hasn't been there for the whole time.
I don't think so. Go team, I think, happened in DR. I think go team was a DR phrase and somehow it just stuck. Or at least DR kids made fun of me saying it. Maybe it was just gas. How about the pipeline? Where did I get this example from? Hold on. That's a good question, David. Did I steal them? Or did I make them? You guys are all wondering why the X and Y is already switched, right?
Yeah.
Hold on.
What?
Ooh! Pause! The directions are different. The directions are different, but why did the same thing as what we've been doing? They wrote it as the inverse.
I always hate to find it.
So you could use the formula with 1 over f prime if you wanted to go back and say, well, if this is the inverse, you could have thought about who is the original. So because they just said find dy dx, they're not saying take the inverse of this guy. They're saying, hey, whoever we gave you, go find his derivative. And you, by looking at it, are like, wait, x and y is switched. This is an inverse. Okay, cool. So use the formula. Whoops. Don't worry, you got this. Use the formula. Or use implicit.
What would you mean? It's kind of smart to put in the formula.
Yep.
Because this was a homework problem.
This exact one and two.
Okay, so if you put if you put y equals
Honestly, you just derive and then plug in.
derive.
Derive and plug in.
You can do implicit, ddx of both sides. Or you can do 1 over f prime. Either one works.
Wait, what number was it? Showing?
It was number.
3x squared
Oh,
minus.
I remember I got this one right.
because the 12, 13, like
Number 19.
Oh,
So 1 equals.
how are you supposed to
Oh,
show
right.
this?
Wait, so d
dy dx
equals 3x squared minus 14. That's it.
You literally derived.
14
But you
times.
just slope this derivative,
And
so
then
you
you
derive
plug
the
it. Wait.
function. Because they give you
Oh,
one verse over that. So the
Wait,
derivatives of
hold
each
on. Yeah, so
function.
it's 1 over.
I think you did it right, but this is confusing because. Okay.
Bro, what do you mean plug in that?
Oh, yeah.
Negative 4.
Okay. So I'm just confused.
Find,
You were plugging negative 4.
Okay, wait, oh, you were 10. Okay, I was looking at this.
Oh, I thought
That's
so sad.
So you drive it, yeah.
Wait, what's the equals you drive? Oh, push.
we can plug in -4.
So you plug in negative 4 once you drive.
Oh, yeah, you give it an inverse.
I thought it's the
This is
1.
right, right? And then you plug in negative 4.
Oh, okay. Oh, so you say
Or do you plug in once it's the reciprocal?
oh, so you're
Plug in negative 4 because it's the x they gave you is
So
the
I
point of,
So
this is F
the x is the x and the y is the
Yeah,
y.
give you a point.
They're just going to take the
Oh,
derivative.
so you literally just plug in both into the formula, and once you get
Question!
the
Who is?
Oh, okay.
Question. Who is? Ooh, David, hold on.
What?
How'd you solve it? Formula or
Implicit.
implicit? Okay. So if it's implicit, we would take ddx of both sides, right?
Yeah.
Keeping everything the way it is, because they didn't say to invert anything. They didn't say to change anything. They said take it as it is and take the derivative. Okay, cool. Derivative of the left is 1. Derivative of the right is 3. Y squared minus 14y.
14.
And dy
Both of
dx.
those are times dy dx. I just factored it out.
Wait, what?
Because
She's factored out the
You keep it as is. You don't switch the x and y, because they just said find the derivative.
Okay,
of
so it's
this
already
x.
switched, right?
Yeah, it was already switched.
Oh, okay.
Sorry. Then divide. Now, they already switched it, so the point they gave to you is the x that corresponds with the x and the y that corresponds with the y. So who am I plugging in? The 1. Because the y is who I need. So it'll be 1 over. But guys, don't we always plug in the y of the inverse? So you just had to realize, oh, this point is the point of what they gave me, who is the inverse. Yeah. But notice the directions said just find dy dx. It didn't say find the inverse of what's given. It just said go. You're like, oh, hey, look, it's an inverse. Plug it in. 3 minus 14 is negative.
11.
11. Negative 11.
Oh, so it is the.
I was supposed to.
It's a slope.
You were just thinking switch because that's what we. If they had said f inverse, we would have switched. So my directions, you were right, but I wrote the wrong directions. I had to go to the book real fast. Yeah, Sarah.
When they ask you that in like that form, and they give you the coordinates, couldn't you just derive and then plug in y?
Yes.
You don't have to do the whole like fraction thing, right?
Well, we didn't have to think about the formula because as you derived, you end up with the fraction. Makes sense? So you end up with the 1 over just by doing implicit.
So you can do that for anything that gives you that.
We could have used the formula by going back to the original. F prime would have been 3x squared minus 14x. But we need the b, so we would have done 1 over that, and we would have plugged in the y value instead.
I say you forgot.
No, I didn't need to
This
prove it.
is yeah,
No.
because this is
No, it's fine.
you find the y prime, not the
And y prime is dy dx.
not the inverse.
Well, I showed you who the original is, just in case you wanted to use the formula, because they gave us an inverse and said find this derivative. And so we found this derivative.
Already inverse.
Yes. Which is why I had to change the directions. Because you weren't supposed to be thinking about taking the inverse of this. Yeah, that's why I just had to change it. Yeah. So you were like, David, if you were following the directions before, you would have had to switch and do the reciprocal. But since I gave the wrong directions, then this is okay, this is right. Kiddos, homework number 13. Wait, 14. Huh? Does anybody know the right homework number? Struggled.
14.
It's 14? Okay.
Are you gonna give us homework?
Is due tomorrow.
Finish what
So
you
you are gonna give us homework.
26B. You see what's on the backboard. I already announced it, you silly goofs.
It's just 2 points.
2.6B. 14? Okay.
Oh,
So the board's right.
Yeah.
My notes were wrong.
man, we're really slowing down on this side.
Oh, yeah. We're all getting good grasp.
Well, there's only 3 sections. 2.5, 2.6, and 2.7, I think. Or is it 2.8? There's only like 3 sections, I think, on or in this chapter. I'm going to freeze the screen so you guys can take notes. Now, wait. All this is pre-cal review, okay? So just getting a general idea, just reminding yourselves of trig. If you guys are watching the video right now, go ahead and pause and take it down. Basically, this entire second half of 2.6, I could just give you formulas and say memorize. I could just give you formulas and say memorize and practice. I'm just showing, yeah, I want you to know why. And not in the crazy, deep, pure mathematical sense of all the different ins and outs to numbers and how they work and how they behave and how they're open or closed under multiplication, addition. Huh? Derivative b of what?
What does the graph look like? Give me the calculator.
For cosecants and secants, they bounce off. Or do you mean the inverses?
No, I'm just telling
I
you
think we graphed it.
what it looks. We'll graph it.
What was I doing? Something very productive. I was opening up.
You're telling us that you don't want us to learn only
Oh yeah, we should
memorizing one of that.
Yeah, I saw I was opening up. It's gone. Okay, E for effort. What a roll today.
So what is
Oh, I know I was opening up the calendar. Anyway, long story short. We only have 2.5, 2.6, 2.7. The 2.7 is a very special type of word problem that I think is the easiest, but it takes a while to get the hang of. 2.5 was implicit differentiation, which you guys know is a beast. And 2.6 all has to do with inverses. We talked about general inverse functions in 2.6a. Now we're going to zoom in on inverse trig. Once again, I could just give you a page with all the rules, and hopefully we'll get to it today, but I want to show you some of the why. Over on the side, the note to fill in is HLT. In order to be 1-to-1, it has to pass the horizontal line test. And to pass the horizontal line test, we take certain sections of these inverse, or of these original trig graphs to find the inverse. We take certain sections in order to make the function or to choose an invertible piece. We call them last year principal branches. And so we restrict sine to be angles between negative pi over 2 and pi over 2. And we know that sine, hopefully, goes between negative 1 and 1. Sine naturally doesn't get any higher than 1 or any lower than negative 1. Cosine, we choose to be between 0 and pi, but it also only goes in between negative 1 and 1. Last year we talked about how sine inverse, we go between quadrants 4 and 1, negative 90 to 90. Cosine inverse, we go between quadrants 1 and 2, 0 to pi. Tangent also goes between negative pi over 2 to pi over 2, but there are asymptotes there, so we have to do open intervals. But his range is all real numbers. He goes forever low to forever high in that restricted region. Technically, tangent would keep going if we needed him to keep going, but we don't choose anymore because it would fail the horizontal line test. Cosecant is 1 over sine, so he ends up having the exact same interval as sine, except he's undefined halfway in between. He's undefined at 0, so we have to split him up at 0. Secant, reciprocal of cosine. He's the exact same as cosine, except, once again, he's going to be undefined halfway in between. And cotangent, well, he just follows, since his denominator is cosine over sine, he just follows sines. But he has vertical asymptotes. He has asymptotes at 0 and at pi. So we can restrict him with open intervals instead. He's also forever low, forever high. This is his principal part right here. Secant's kind of nasty. That's his principal part. And cosecant's kind of nasty. That's his principal part. How high? Negative infinity up to negative 1. Then from 1 to infinity. Negative infinity up to negative 1. Then from 1 to infinity. Open and close. Now technically, guys, we kind of have this stuff in our basic graphs, right?
Yeah.
I'm just trying to give you a quick visual. That you can look at when you're doing 2.6b as far as if you need to solve for actual inverse trig values, etc., etc. I've been starting all these sections with pre-cal review. So this is pre-cal review. It's not something that you have to memorize every single one. It's just like if it does come up, you know you have it in your notes. As far as if you're doing sine inverse, cosine inverse, you have to look only in between these angles, depending on which inverse you're looking at. Because when you go to the inverse, the x's and y's switch. So this restriction is going to be the answers, the only answers you're looking for when solving inverse. Anyway, you have them in your notes. This is probably the most tedious part of this section to take down. Cosine. Pi over 2 to pi. Oh, sorry, pi over 2 to pi. The rest of the pre-cal review is a little bit easier, which is next. Just the graphs are messy. I wanted to help you visualize, not just from your forever card, like the basic shapes of them, but also what portions we steal for inverses. Now, the other pre-cal review. Go ahead and skip however much space you need. You can look online or on the video. Copy down any more detail that you need. But the other pre-cal review. Remember what's going on. If we have a normal trig, you put in an angle. Example could be pi over 6. You put in an angle, like pi over 6. And you get out a ratio, which technically does stand for opposite over hypotenuse for a right triangle. But if you put in, for instance, pi over 6, you should get out 1/2 for sine. So you put in an angle, pi over 6, you get out a ratio 1/2. That's how trig normally works. But with inverses, since everything is switched, instead you're putting in for inverses. You're putting in ratios, for example, like are 1/2, and you're getting out an angle, which our example would be f of pi over 6 for an inverse. F of 1/2 of an inverse would lead us back to pi over 6. So remember what's going on with inverse. Instead of putting in an angle, getting out a ratio, we put in a ratio, we get out an angle. So for inverse in general, given a sine, cosine, or tangent value, aka a ratio of sides, they don't tell us it's a ratio. We have to understand that. We're supposed to find the angle. We're supposed to find the angle. So that's just a general idea, again, of who an inverse is. An inverse takes a ratio in, spits an angle out, as opposed to normal trig, taking an angle in, spitting a ratio out. Let me leave the pre-cal practice till tomorrow. I want to get to the calculus idea, which is the next slide. Let me get to the calculus. We'll do like a little pre-cal with you at the beginning of this one, as far as solving ratios. Here's the crazy thing. If they give us y equals sine inverse of x, and if we don't know a formula for sine inverse, well, we'd have to say, well, what can we do? I guess we could take sine of both sides, exactly. We know how to deal with sine, just not sine inverse. So what if we take sine of both sides? What happens with sine and sine inverse?
I can't.
We cancel, and we just get the argument left.
Yeah.
So now we have sine of y equals x.
So let's just do.
Now pause. Isn't y an angle? Then what's x? A ratio. So couldn't I say opposite over hypotenuse is equal to x over 1? So I could say for angle y, opposite is x, hypotenuse is 1. Does anybody know how I could solve for a formula that expresses the other leg of my right triangle? Yeah, isn't a squared plus b squared equal to c squared? So to solve for a squared plus x squared is equal to 1. A is going to be equal to the square root of 1 minus x squared. I can actually fill in the third side to my triangle. Now, how does that help? Well, can't I do an implicit derivative, taking the derivative of both sides of sine? Derivative of sine of y would be cosine of y times dy dx. Derivative of x is 1. dy dx is going to equal 1 over cosine of y. But who is cosine of y looking at my triangle? So this is going to equal adjacent over hypotenuse. If I have a triangle, can't I go looking for it? The angle is y, the ratio is what I'm looking for. That's going to be 1 over adjacent. Oh, and the hypotenuse is just 1. The derivative of sine inverse of x does not involve any, or does not include any trig expressions. It only includes a ratio of a triangle that we can form. Now, kiddos, you just discovered the first trig rule
What's the first trig rule
of inverse trig. The derivative of sine inverse of x is equal to 1 over 1 minus x squared. Or if it was a u, sine inverse of u would be 1 over 1 minus u squared times u prime. How many trig rules are there in total?
25.
6 of them, because there are 6.
Oh, yeah.
6 of them, because there are 6 trig rules. Now, sadly, our time today is done. But I'm going to go ahead and write down these 6 trig rules because basically, in homework, do you have to find the formula or just use it? Use it. So once you have the formulas, man, if you can keep going tonight, keep going. Because all you need to do is say, I have some new formulas, let's see if I can use it correctly. We'll talk about why some more of them are what they are tomorrow. But so far, we just filled in this one. I'm gonna go fill in the rest. Bye, cool kids.
I wish that was longer, just saying.
I was doing
Bye, guys. Happy Wednesday.
We didn't have to go to English. We could take like 2 classes and she understood.
Bye. You guys are so different than most of the world. They'd be like, get me out of there.
Do you take it off midday?
Well, no, I take off the jacket first and then take it off. I take this off of the
Yeah. Grab it this morning. I'm sorry, kiddo.
A lot of people turned in their homework spirals the day after the test and being like, or actually it didn't be a time to grade it. So they might just be picking up their homework spirals. Kiddos, if you need your homework spirals, they are on the front table. Go